Hello and welcome to this episode of Math with Martinez. In today's video, we are looking at piecewise functions in this unit on functions and their graphs. And today we're looking at what happens on the left side and on the right side of our graphs of functions when they have discontinuities. So let's begin with discussing what are piecewise functions. They are functions that are made up of two or more functions, and each function will have its own domain, each function with its own domain. Take, for example, this function here, f of x. It is a piecewise function because it has 1, 2, 3 pieces. It has 3 separate functions. It has an absolute value function. It has a quadratic function and a square root function, and for each of those, it has a separate and unique domain. And so what I want to begin by doing is just kind of identifying, based on what value, which piece we would be looking at. So let's begin to find each value given this piecewise function, f of x. For this first function, I want to go ahead and highlight the different portions here. If you have a highlighter, please do the same. And now that they're highlighted, let's begin to talk about these different pieces. The function at -5, we want to evaluate the function at -5. So we need to ask ourselves, well, which piece has -5 in its domain? That's what we want to ask ourselves. Let's make a little note here and ask ourselves which piece has x equaling -5 in its domain. That's what we're curious about. And then we will use that piece of the function to evaluate it. So let's look at the first piece, this absolute value. That occurs when x is less than -3. So x values less than -3, what values would that be? Well, on your number line, if you're thinking about that, here's 0, here's 1, 2, -3. Those values less than -3, that's going to be everything on this side, and it would be an open circle right there, right? That's that first portion. Then the next portion is from -3 to 7. Oops. There's 3, 5, and there's 7. So this next portion here is x values between -3 and 7. It includes the -3, and then we have this open circle at 7. And last but not least, that green section is everything after 7. Everything after 7. X values greater than and equal to 7. So where are we going to be if we're talking about when f is -5? Which piece would we be in? The yellow, the red, or the green? Which piece includes x values that are going to include -5? Well, ladies and gentlemen, that would be this yellow section. We want to look at the yellow piece of our function and evaluate that. To do so, it would be to take that -5 and substitute it in to the rule for that piece, which is the 2 times the absolute value of your input minus 5. Well, what does that equal? If you went ahead and simplified that expression, well, you're saying, really, this is the same thing as 2 times the absolute value of 10. The absolute value of -10 is 10. And so the product there is 20. Our function at -5 is 20. Let's try now the next little portion here. We want to evaluate our function f at 2. So which piece will we be utilizing if we're saying when x is equal to 2? Remember, for the first one, our x was equal to -5. For this next one, we're saying x values equaling 2. Which piece includes 2 in its domain? The yellow, red, or green? All right, well, ladies and gentlemen, that would be the red piece. 2 is included in that red section. It is right here. So let's go ahead and evaluate that. We're going to say our function at 2 is going to be opposite of our input squared plus 4 times our input. Ladies and gentlemen, can you take a moment to figure out what that would simplify to? What is our function at 2? All right, well, it should be 2 squared. 2 squared is 4, but it is still being multiplied by that negative, so it's -4 plus 8. Our function at 2 is 4. All right. Ladies and gentlemen, last but not least, let's evaluate our function f at 7. Our function f at 7. Which piece will we use? Which piece will we use? The yellow, red, or green piece? Since we're saying x values equal to 7, we're between the red and green, but which one includes? Which one says x values equal to 7? That's going to be our green function because it says x values greater than or equal to 7. So into that function rule, we will substitute 7. We're taking the square root of 2 times our input, and then we're adding to that 6. This is the square root of 14 plus 6. 14 plus 6, 14 plus 6. That's going to be the square root of 20. And that is not a perfect square. We're going to ask ourselves, okay, how could we rewrite that? I could rewrite this as a 4 times 5. So this is 2 square root of 5. 2 square root of 5. My function at 7 is 2 square root of 5. There you have it, ladies and gentlemen. That was the little intro in this first part that I wanted to share with you all on working with piecewise functions and evaluating them. Stay tuned because next we'll look at graphing them. Until then, if you had any questions, please take a moment to share those now. And until next time, stay fired up, you guys.